Hello, welcome back to the lecture series on microeconomics. So, we have finished our discussion on Cournot and Stackelberg duopoly models, which are basically examples of non-collusive oligopoly models. Now, we are going to end our discussion on oligopoly market models by discussing another type of model which is called collusive oligopoly. Now, what do we mean by collusive oligopoly? Previously, if you note that in the case of Cournot model, the firms were unaware of each other's output decision and they used to take others output decision as given and used to set their own market quantity. In the case of Stackelberg model, the leader firm used to set the quantity or market supply first in the market and the follower firm has to follow. So, basically in these two types of models there is rivalry between the duopolist firms to capture the market share and to attain a higher level of profit. But what if they shake hands, if they become friends and if they want to work together, then they will become basically a monopoly power, because if there are only two firms and if they kind of go for joint profit maximization, then there is only one firm. So, that kind of situation is called a collusive oligopoly model, where basically the rival firms meet and then they strike an agreement, so that they take output decisions which are good for all of them. So, basically under the collusive oligopoly model, firms enter into a pact and then they decide on each individual firm's output level in such a way that the aggregate output level maximizes their joint profit. So, now we are going to look at one example from real life where this type of model is applicable. Most of us are aware of this organization called Opec. So, those who are not, for them let me tell you the full form of the organization's name. So, it is known as the Organization of Petroleum Exporting Countries. So, this organization is a major cartel of crude oil producing countries. So, now they have 15 countries as members and this organization was founded in 1960, and since then they had a huge say in the world crude oil market, and they influence the market price of crude oil heavily. So, how does this kind of organization work? We really do not have a very good answer for that, but of course, we can try to model their behavior, and so here in this lecture we present one such simple model to explain the behavior of collusive oligopoly, or sometimes known as cartel. So, we start with the definition of cartel. When okay, so now Before we start with the model for a cartel, let us make some assumptions which are very critical. So, let us start with some assumptions behind this type of models. Okay. So, the first assumption should be that each firm knows the correct form of market demand and cost structure of each participating firm. Right, okay. And then we have to also assume that once an agreement towards joint profit maximization is reached, then there is no cheating. Cheating makes a cartel unstable, and we will see that there is every incentive for cheating in this model. Okay, so now let us get into the model part. Okay. So, here also we are going to assume that we have only two competitors in the market. So, it is basically a duopoly model. The only difference from the previous models is this: here they want to cooperate with each other and they want to basically take joint decision to maximize joint profit. Okay. So, now the model would be like maximization of joint profit, which is basically the sum total of individual profits of my firms 1 and 2, right. Okay. Now, the demand function is given. So, now I can write the demand function, of course the inverse demand function, as P equals some function of Q1 plus Q2, the individual output levels. Okay. Now, we also assume that the cost functions are different. So, for firm 1 we have some cost function which is given by some function G1 of Q1, and for firm 2 it is given as G2 as a function of Q2, right. Okay. So, now we are in a position to write down the next step for our profit function. So, basically we can write price as a function of Q1 plus Q2 times the total supply in the market by these two firms, and of course we need to subtract the costs. So basically this will become C1 of Q1 minus C2 of Q2, right. Okay. So this is what we start with. So now we have to derive the first order conditions. Okay, so now we are going to find out the first order conditions of this profit maximization problem. So we would like to take these derivatives and this will become we need to set that to 0 and that basically leads to MR equal to MC1, right. Okay. Then of course the next derivative follows and we have MR equals to MC2. Okay. So these two are basically my first order conditions. So combining these two, I can write one single first order condition for joint profit maximization, and that is this. So basically what do we mean by this? We mean that the cartel's marginal revenue shall be equal to the individual firms or participating firms marginal costs for the optimal quantity level. Okay. So now it is time to have a look at the second order condition. Now the second order condition is given by del square R by del Q I square less than del square C I divided by del Q square I. So here I takes two values, right. So this is also similar to what we have seen earlier. So rate of change in marginal revenue, which is basically given by this expression, shall be less than the rate of change in the marginal cost. So basically that means that the marginal cost curve of the firm shall cut the marginal revenue curve from below. Okay. So now let us going to have a look at a diagram to find out the solution to this problem. So now I move on to a graphical analysis to find the solution in this cartel model. So I will have 3 panels of diagram. So in panel A, I have the necessary curves for my farm 1 or duopolist 1. Now in panel B, I have the curves which are required for analysis for farm 2, and in panel C, I have the aggregate picture. Okay. So I start with farm 1. So its output is measured along the horizontal axis, and here in the vertical axis I measure the price and the marginal cost of production. So same here for farm 2, and here we have the total production, right. and here also we have this B comma C. Okay, fine. So now we are going to first draw the cost curves for farm 1 or duopolist 1. So of course it will have some average cost of production which is given by AC1, and corresponding to that the farm will also have the marginal cost of production curve MC, which will pass through the minimum point of average cost. These things are known from my theory of cost, I hope you remember, and this is my marginal cost curve. Okay. Now we are going to have the curve for farm 2. Now here note that we do not have to assume that they have the same cost structure. So in fact let me assume that my farm 2 is a high cost producer. So its average cost curve AC2 lies totally above the average cost curve of farm 1. But for this farm also we will have a marginal cost curve which passes through the minimum point of the average cost curve, right. Call this MC2. Okay. So now how to solve the puzzle, how much output to be produced in this market? For that basically we have to follow a trick. Okay. So before we go to panel C and start discussing how the optimal level of output to be produced, in this case I would not say optimal, I would say equilibrium level of output to be produced in the market, we have to see how these farms are going to decide to produce. So here in this market there are two farms, right, and each of them has marginal cost curves. Now we have seen in the competitive industry analysis that if we have two farms with two different marginal cost curves or even identical marginal cost curves, we have to aggregate these marginal cost curves to find out the industry supply or the aggregate supply curve, right. So basically that part of marginal cost curve which lies above the average variable cost curve is basically a particular farm's supply function, and these supply functions have to be horizontally added. So basically for a particular price level or marginal cost level, we have to first find out how many units of output farm 1 is going to supply, and at that same marginal cost or price how many units of the product farm 2 is willing to supply. We need to add them, and that sum total gives us the industry supply for that particular marginal cost number or price. So we are going to adopt the same strategy here to find the industry supply. So now let us sum these two marginal cost curves. So as these marginal cost curves have different slopes and different intercepts, there will be a kink somewhere and it will basically give rise to some kind of marginal cost curve like this. Here note that there is a kink point, okay. It is due to the difference in slope and intercept of the individual marginal cost curves. So this is basically my total marginal cost, which is basically the horizontal sum of marginal cost 1 and marginal cost 2 individual marginal cost curves. Okay. So now the only thing that is left here is to impose the demand function of the market. So basically now we can superimpose the market demand curve. The assumption is that the cartel knows the market demand function. So this is given by D. So if that is known to the cartel, now note that the cartel will now behave as a monopolist, right, because there is no second person in the market to supply. Okay. So, if that is the case, then the monopolist cartel can derive the marginal revenue function in this case, right, and that is given by this blue line, and at the intersection of the marginal cost curve and the marginal revenue curve, the cartel's equilibrium is determined. So, somewhere here. Okay. The red point, the king point, and the gray point, which is basically the cartel's equilibrium point, seem to be same, but actually it is not. This is just by fluke because of hand drawn diagram. So, please do not be under illusion that the cartel's equilibrium will always lie at the king point of the aggregate marginal cost curve. It is not. So, here we get Q star, the total market supply, which is basically the sum total of individual supplies, right, and we know what to do now. As we have done in the case of a pure monopoly model, we have to move up from this point to the aggregate demand function for the commodity, and we know that we have to now move to the aggregate demand function for finding the price that this cartel is going to set in the market, right. So, this is the point, corresponding point, this is the point on the demand function corresponding to the optimal or profit maximizing output quantity level. So, at this price, this is the price that the cartel will set in the market for its product. Okay. So, now let us study how many units will be produced and supplied by these participating duopolist firms, right. So, we have to now equate this common marginal cost, which gets equated to the marginal revenue, and we can call this as some marginal cost bar, which is basically the common marginal cost. Now, note that here this MR equal to MC is found, and this firm 2 produces Q star 2 level of output, and here at this point the MR equal to MC1 condition is satisfied for the participating firm 1. So, the duopolist produces and supplies Q star 1 units of output to the market, and if you sum them we will get Q star, the market output. Now, note that here as the firm 2 has a cost disadvantage, or we can say that our firm 1 has a cost advantage because it works with the lower level of average cost and marginal cost of production. So, here we can say that if the marginal cost curve always lies below than the other participating firm, then the firm which has that kind of cost advantage will necessarily produce and supply more output in equilibrium in this cartel model. So, here we can see that this Q1 star output level is basically higher than Q2 star output level. Okay. So, we are done with our discussion on joint profit maximization monopoly model, and this is more like a multi-plant monopolist. So, basically here comes a monopoly and here comes a monopolist firm which has different plants. So, each of these participating duopolists will now become different plants in this cartel model, and together they go for joint profit maximization. So, one can also read this model as a multi-plant monopolist model. So, with this discussion on cartels, we conclude our discussion on imperfect competition market models. In the next lecture, we are going to go through these types of models and their solutions through numerical exercises for better understanding. So far we have done all this modeling through general functional forms. There we are going to assume explicit functional forms, so that it will be easier for you to understand how to solve these types of models if simple functional forms are given.